talk about the last stress in equilibrium problems. So this is the last video to talk about Le Chatelier's principle, how systems at equilibrium respond to stress. The last stress is pressure. Now, concentration and temperature were very similar. We used the ruler or your pencils. We figured out how it would cause it to go out of equilibrium, which side we have to push down to get it back. The side we have to push down is the side of the shift. This one is different. This one we have to think about completely differently. So, in my opinion, it's not that bad. A lot of students actually tell me this is their favorite one. But it is different. It has different sets of rules. So, first of all, let's talk about the gas law unit. Remember, a few units back, we learned that when a system changes its pressure, it's not happy. Do you remember that? Two different areas of different pressure, the gas is going to be moving until the pressure is the same at both, or it's going to at least attempt to move. Situations that are different does not make gases very happy. So first of all, I do want to tell you that pressure only affects gases. So if you have a system of aqueous, pressure won't be affecting it. Only gases. So if you ever see some solids or liquids, well, you cross those off always for equilibrium problems. But gases only, if you see aqueous, will not be affected by pressure changes. Okay. So let's think about it. If you increase the pressure of a system, would you agree that the system would want to decrease the pressure? And if you decrease the pressure, the system's going to work really hard to increase the pressure. The way it's going to do that is by shifting the reaction. It's either going to shift to the right and produce more products, or it's going to shift to the left and produce more reactants. Remember, the direction of the shift is the side that's increasing as a result of the stress. So let's think about this. If we are increasing pressure, this is the way the system is going to get it back. The reaction itself will try to decrease the moles. Because if you increase the pressure, it's not happy. But if you decrease the moles of gas, that's going to cause that pressure to go back down. Decreasing moles of gas decreases pressure. So if you increase pressure, it's going to attempt to decrease the pressure by decreasing the moles. Same if you decrease the pressure, system's not happy, it's going to increase the moles. So here's what you have to do. Count the moles of gas on both sides. And if you increase the pressure, it's going to shift to the side with fewer moles. If you decrease the pressure, it's going to shift to the side with more moles. So they kind of go in opposite, because it's trying to get it back to where it was. So let's look at our first example. We're looking at the same equation we've been looking at throughout. Increase the pressure. We've got to count the moles of gas. That is your coefficients. Count the coefficients. We're going to count the particles on both sides. So this side has 1, 2, 3, 4. This side has 4 moles of gas. This side has 2 moles of gas. If you do ever get a situation where both sides are the same, pressure would have no impact. So you would say no change. In this case, they're not the same. If we increase the pressure, they're going to want fewer moles of gas. Increase the pressure, we need less moles to get that pressure back down. So it's going to want to shift this way. It's going to want more of these. So shift to the side with fewer moles. Shift to the right. What does that mean? It means this side is increasing, and that means this side decreases. So NH3 increases. And our reactants, N2 and H2, and H2 decrease. Now this next one is going to do the exact opposite, but I'll erase some stuff just to show you. In this same system, we still have 4 moles of gas over here, 2 moles of gas over here, and that's the coefficients that I'm counting to get those numbers. So if we decrease the pressure, it's like, oh man, I don't like this. I want to get that pressure back up. You know how we're going to do it? Produce more moles. It's going to shift the reaction this way, producing more of these. If we produce more of these and less of this, now we have fewer moles in the system, getting that pressure back to where it was. Shifts to the left. So that means our reactants, N2 and H2, will increase. Whereas our product, NH3, decreases. Now, do you remember if K, the KEQ constant, is it affected by pressure? Will it change? No, the only thing that changes K is temperature. So K, constant. No change. Makes it a little easier. You don't have to figure out why or where or how. Good. Let's do this next one. First thing you should do is count moles of gas. This side, we have 2. We're counting the coefficients. This side, we have 1, 2, 3. So if we have increased pressure, we're going to want fewer moles. That's going to shift left. That means everything on the left is increasing. So SO3 increases, and SO2 and O2 decrease. Because we want fewer moles of gas when we increase the pressure. Increase pressure, fewer moles. That means that this is going to increase, these will decrease. The side that has the fewer moles will increase for increased pressure. The side with the more moles will decrease when you increase the pressure. Let's talk about decreasing the pressure. If we decrease the pressure, the system's like, oh no, I don't like where I'm at. I want to increase that pressure back up. The way we're going to increase the pressure is by decreasing the way that we have decreased pressure. The reaction as a result will increase the number of moles to get that back. So we decrease the pressure. We need more moles of gas. That means this side will increase. And that means that this one's going to decrease. Notice it's the exact opposite. It's going to shift it to the side with more moles of gas. This one's actually going to shift right. So it's going to give us the exact opposite of the answer above. Right here, the exact opposite of this. Shift right. SO2 and O2 will increase, and SO3 will decrease. How will K change? Ooh, that's a trick question, because K won't change at all. K will stay constant. Whew, all 3 stresses done. Here's the best thing you can do now. Do the practice that's in your note packet. Do your homework tonight. Practice makes perfect with this. There are patterns with all 3. So either learn how to use the teeter-totter, the seesaw, learn the pattern here, or you can just memorize patterns for all of them, but you do need to figure out how you're going to get these answers right each time. So good luck.